For this video, we'll be going through the practice paper for electricity for lower sec science. Okay, so question 1, what is the effective resistance of the following resistor? As you can see, all these three are actually connected in parallel. How do we tell? We role play the current example, if it flows to here, then at this point it will actually split into three paths. Okay, so this is how we determine that whether they are connected in series or parallel. So if it's in parallel, then you actually have to calculate the effective resistance using this formula, plus 1 over R2 plus 1 over R3. Okay, so the effective resistance I just put in sequence, 1 over 2 plus 1 over 4 plus 1 over 6. So again, if you have a calculator, it will be much easier. This will be 6 plus 3 plus 2 over 12. Okay, so really please have your calculator. Therefore, it will be equals to 11 over 12. Now I'm looking for REFF and not 1 over REFF, so I flip both sides. 12 over 11, I'll get something like 1.09. So answer will be B. Okay, next, 3 similar light bulbs are connected to a voltage supply. We have 2 ammeters of negligible resistance attached to different parts of the circuit. The filament of bulb F melts and breaks. When this happens, it actually creates an open circuit. So the current will no longer flow through it. It's sort of taken out of the circuit. Now what will happen to both ammeter reading? So bulb F is broken, right? So now we only have current that flows in here, the first bulb. I call this bulb 1 and flows in bulb 2. Okay, so the current that is provided by the battery, because initially I have 3 paths that the current can flow through, but because this bulb is no longer working, no current can flow through, so I only have 2 current flow in the first path and the second path. Therefore my ammeter reading will get lesser. G will decrease, right? Because initially I have these 2. Okay, how about ammeter H? Okay, so I'm going to use analogy instead of using math to convince you. Okay, so example, you have 3 rooms in your house. 3 rooms in your house. Okay, so it's actually as if it is, I have 1 room, 2nd room and 3rd room. All 3 rooms actually have light bulbs in there, right? Lights in there. So when I turn on the lights for all 3, okay, individual 3, because they are not connected in series, they are connected in parallel, like the house lights in your home. Let's say, example, your parents off their lights. Will your room light become brighter or less bright, or remain the same? It should remain the same, right? It doesn't matter, right? Therefore, the current that flows through ammeter H will remain the same. So the answer is B. Okay, so that's the thing about parallel circuit. Whether or not the another room's light or another light bulb in another path, whether is it on or off in parallel, as the voltage is the same, okay, as the voltage across each light bulb is the same, okay, the current will only be determined by the voltage across the light bulb. It will not be affected by whether the other path lights are on or off. Okay. Question 3, which of following statement correctly describes a hairdryer with a power rating of 5 watts? Okay, we have seen this in our notes. It was a 60 watts light bulb, right? And actually 5 watts is very, very low lah. So this is just a question, yeah? So it converts 5 joules of electrical energy. That is true. 5 joules. This is wrong because we cannot start off with heat energy. Okay, we always start off with electrical energy, so C is incorrect. So D is also incorrect. So basically it converts 5 joules of electrical energy into heat energy. That is true in every 1 second, right? So this is true. So answer is A, not 1 hour. When do we use hour? Okay, when you are calculating kWh. Okay, when you are using kWh, which is energy, let me do a very quick grid here. Okay, when we are calculating energy in joules, right? Energy, your energy is power times time. Okay, this is the formula that you need to know. So this is my energy. This part is power. This part is time. When I want my energy in joules, my power must be in watt. I'm going to include the symbol as well. Okay, my time must be in seconds. Okay, but when I want to calculate my energy in kWh, okay, so basically the units is kWh, kilowatt hour. Maybe I should tell this here, kilowatt hour. Okay, then my power must be in kilowatt. Okay, it must be in kilowatt, and the time must be in hours. So the unit is H. So if I multiply these two together, I get kWh. I multiply watt and seconds together, I get my joules. Okay, so you might want to take note of this. Now, fluorescent lamp is rated at 75 watts, so this is the power. Write down the P. What's the total electrical energy? E, if it's used for 30 days non-stop. That means it is on 30 days. Okay, now if you look at the options, they tell us to calculate the kWh. So if you refer to this, in order to get kWh, the formula is E equals to power times time, right? They want us to find the E, right? Your power must be in kW. Your time must be in hour. Therefore, the unit for energy can then be kWh, right? So this is a clue given in the options. So firstly, let's try to convert the power into kW. The power is 75 watts. Okay, is it in kW? No. So I have to convert it to kilowatt. So I divide by 1000 to get 0.075 kW. Okay. Now the time, they just say 30 days non-stop. Okay. Therefore, 1 day, it is 24 hours. 30 days, it will be 24 times 30 hours. So I will get 720 hours. Because I want the time to be in hours, I already have it in hours. So now let me calculate the energy in kWh. My power is 0.075 kW. My time is 720 hours. So the final answer will be 54 kWh. You absolutely need your calculator. Answer is A. Okay. Now question 5, it shows an electrical circuit containing 2 light bulbs, one with 40 ohm resistor. There you have it. So this is the R, while the other one has an unknown resistor. So maybe I call this R1, I call this R2. So R1 is 40 ohm, R2 is unknown resistor. And how are they connected? They are connected in series. Okay. The voltage by the battery is 6 volts. On figure 5.1, draw a device that can be used to measure the potential difference. This one will be using a voltmeter, and voltmeter must be connected in parallel. Okay. So they want us to draw a device that can be used to measure the potential difference of the 40 ohm light bulb. We have 2 light bulbs, so we have to draw the voltmeter across, which is parallel to the 40 ohm. So this is the answer. Okay, there's 1 mark given. Don't miss this out. Now, the ammeter shows a reading of 0.10 ampere. So what does ammeter measures? It measures current. what is the symbol for current? It is I. So we have our I, which is 0.10 ampere. Calculate the potential difference of the 40 ohm light bulb. 40 ohm is your R. So use the formula V equals IR. The V is unknown. The I is 0.10. The R is 40. So it will be 4 volts. 4 volts, yeah? I'm thinking they may ask us to calculate the voltage across R2. Calculate the resistance. No, they want us to calculate the resistance of the unknown light bulb. So can I just redraw the circuit here so that it looks nicer, more familiar to you? Okay, so this is 6 volt. This is the 40 ohm light bulb. This is the R2 unknown. Now I know that the potential difference from part 1, the potential difference here is 4 volts. So imagine my battery is 6 volts. The 40 ohm battery, the 40 ohm light bulb already took up 4 volts. So what is left of this? It will be 2 volts. Okay, how do I get this? So remember this thing that I asked you all to draw, series, parallel. So it will be sum, same, same, sum. But what is sum in series? Is the voltage. What is same in series? It is the current. Alright. What is same in parallel? It is the voltage. What is sum in parallel? It is the current. Okay. So now since we are dealing with series, we only need to focus on this row here, which means the voltage is the sum. Right. So I have two light bulbs, 40 ohm and R2. If the 40 ohm takes up 4 volts, therefore, if the voltage is sum, here must be 2 volts because I started out with 6 volts. So 4 plus 2 is equals to 6. Just now, I know that the current that flows in the circuit is 0.10 ampere. And we know that this is a series. Therefore, the current that flows through the R2 is 0.1. The current that flows in the entire circuit is 0.10 ampere. Because there's only one path, so the current should be the same. So if you look at R2 now, you ask R2, hey, R2, what is your voltage? He will tell you that it's 2 volts. How do we get this? It is from 6 minus 4. How do we know? Because in series, voltage is sum. Then do we know the current? Yes, it's 0.10 ampere. So therefore the R will be V over I equals to 2 over 0.10. So I will get 20 ohms. So the resistance is 20 ohms. Okay. Now part C, the bulb with the unknown resistance was removed as shown. Describe how you expect the brightness of the 40 ohm to change as compared. This is simple. Before that I have this light bulb, but now it is gone, right? Therefore I have a lower effective resistance, but my voltage is still the same, right? So using V equals to IR, my voltage is 6 volts. Okay, my current is unknown because they want us to expect the brightness, and the current is actually telling us how bright it is. Okay, roughly speaking, the resistance is 40, so my current is now 6 over 40, which is 0.15 ampere. I was using my calculator, so please have your calculator. So the current is 0.15 ampere. Compared to previous, it was 0.10 ampere. So the current actually increases. Why did the current increase? You have to explain, right? Because the effective resistance or the resistance in the circuit decreases, right? The effective resistance decreases because I remove it, okay, and not become an open circuit. So if the current increase, the brightness therefore will increase. Okay, so if you have done the mathematical proof, you can also put in here. Okay, question 6, it shows a parallel electrical circuit. If I don't tell you it's parallel, would you know it's parallel? Current comes out, comes to this point, they actually have a few paths, right? So more than one path, it is considered parallel. Okay, So on figure 6.1, draw an arrow that represents the direction of electron flow. So the answer will be, maybe I use a different color. Okay, so this is the electron flow. Please don't miss out this one mark, electron flow. Okay, why is it so? Because electron flows from the negative, current flows out from the positive terminal. Now they want us to determine the potential difference across the 3 ohm resistor. Now look at the 3 ohm resistor, it is connected in parallel. So shall we use this parallel series and parallel sum to explain? In parallel, what is same, what is sum? The voltage is same, the current is sum. Sum meaning additional, same meaning the same value. So the voltage is the same. So if we look here, this voltage is 12 volts. So the potential difference across the 3 ohm will also be 12 volts. In fact, it will be 12 volts for all of them because sum, same. In parallel, the potential difference is the same. So what is meant by the current? Current is rate of flow of charge. If you memorize this, it's just 1 mark. You get your 1 mark. They therefore ask us to calculate the current flowing through the 3 ohm resistor. Okay, so this goes to this, right? You need this, then you can solve D, which is the potential difference across the 3 ohm is 12 volts. How is it 12 volts? I told you, in parallel, voltage is same. Same to what? Same to the potential difference or the voltage of the battery. Current is sum. Okay, so let us calculate the current flowing through the 3 ohm resistor. V equals to IR. I know that the voltage is 12. The current is unknown because it's I. The resistance is 3. Therefore, my current will be 12 over 3. Make sure you do your math properly. I'll get 4 ampere. Okay? And that's all for this chapter, for this worksheet. For this worksheet, we are actually talking more about the series and parallel connection. Okay, so it's important to take note of this.